हेलो गाइस। तो आप सभी लोग कैसे हो? So yesterday we have shown linear regression, right? So from today we are going to continue deep learning session and how deep learning is going to work. So please be active and be ready and take your paper and pen with you, and we will going to start for that. Okay. So let me just share my notes. Okay. So firstly, we have to understand what is deep learning, right? Deep learning. Before deep learning, we have already understood a core concept of ML, and we have seen that how linear regression work, right? Linear regression work. Okay. So in linear regressions, how we train the model and get the value of M and B. Okay. And for that we use GD, right? GD, I will be in upcoming time I will be teach you GD as well. Okay, so you will be going to get more understanding about the deep learning. Okay, so why deep learning come into pictures? This is our big first question, because machine learning is already doing the prediction, but there are some scenario where whenever we have to find out some complex pattern, like I'm going to just give you a uh, graph structure. Okay, so our data is like that. Okay, see, in that data, if new data will be come into this area, so how our machine is going to find out that this pink color data is belong to this white group? This is basically a white group, and this is yellow one. These are yellow one. Okay, yellow. So how? So by linear regression, we only can draw a single line. But here you can see, if we will be try to draw a single line for the yellow line, then here some points are going to miss out by the machine. If new data point will become here, then it will be so white, right? So it is not a correct, right? If we will be draw like this, then also it same problem. And if machine will be understand this side is yellow, then this side is not going to be understand by the machine. So for this kinds of complex uh, pattern, okay, we use deep learning. Okay, in deep learning we can find out the pattern in any complex data. Okay, and that is going to help us to train our model, and that model we can deploy, and for that deployment model we can get more accurate predictions and accuracy rate. Okay, so deep learning is basically you can say that it is come under the ML only. Okay, means it is in deep. Okay, detail what will say detail knowledge. Okay, ML is also a part of AI. Okay, so this kind of the structure they make. Okay, so now we are going to understand the definition of deep learning. Okay, so deep learning is basically a ML subset. Okay, you can say that, right? Okay, this is the subset of ML. Okay, where we make more complex predictions, more complex predictions, right? the, and this is all of our task of the AI, right? So whenever we are training any AI, that AI is going to be work for more complex. And if any AI is working on more complex prediction, understand that that is must they are using deep learning. Okay, so deep learning basically use ANN techniques. Okay, artificial neural network, and this ANN is similar to our brain. Okay, so the way we learn after seeing anything or after touching anything, what we feel like is any pot is hot or cold, all the things is done by the brain only. Okay, so in same way we make a artificial brain, that is not accurate brain, our brain, but yes, you can say like that. Like whenever you are going to touch any hot kettle from your finger, then your brain is telling that yes, that portion, that area, if you are touching from this finger side, then that finger is sending only signal to the brain. Okay, so understand, it is sending 1111 as a hot, and other value is going to be 0. So understand like that, in single touch we have sent multiple input at us to the brain, and other outputs are also continuously going to the brain through the nerve system. But in that situation, the all other values are 0. So in same way, ANN is going to be work for us. Okay, where we have some neurons. Okay, we have some neurons and we have some values x1, x2, x2. These are the input value. Okay, x4, x5, multiples. Okay, that x1 is going to be sent to all the neurons. Okay, and then x2 is also going to be sent to the all the neurons. X3 is also going to send to the all the neurons. X4 is also going to send to the all the neurons. X5 is also going to send to the all the neurons. These all are the connected to each other. Okay, maybe some more hidden layers in between them, like this only. They make mesh structure. Okay, mesh structure in networking, you may know, if you understand, like all the nodes are connected to each one. Here you can understand there are more percetons. Okay, these are basically called percetons, and if you are combining this all thing, this will be called as a hidden layer. Okay, hidden layer, and hidden layer is the combination of percetons. Okay, and at the end of end, if we have a linear regression problem, means we have to find out, predict the data from the continuous data like this, then at the end we have only single percenton. If we have a classification problem, so like we have to find out the it is written digit is like 5 is a number, 5, how we will identify 5, means in classification like 1, 2, 3, 4. If we had to classify between this one in what the input is written with, uh, that time the output is not going to be in single percent, that will be going to be like 10 only. Okay, output, this one is output layer. Okay, I'm just telling you in output layer what we do. Okay, output layer. Okay, so it totally depend on the situations. Currently this diagram is showing that it is for linear regression problem. Okay, so maybe we have one question, like if x is connected to all, x2 is connected to all, then if we will see here, here also these 5 nodes come, here also 5 nodes come, here also 5 nodes are connecting. Okay, but the difference is that their weight here in purple color everywhere, there will be some weight for each and every uh, connections. Okay, w1 you can call as a w1, w2. There is one naming conversation I will tell you further when I will teach you perceptron, but just understand these all are the weight, and weight value are initialized in by using different method. Okay, we just have to identify what will be the correct weight to initialize the weight. Initialization, I'm telling you, initialize. Firstly we initialize, then after making this whole neural network, then we will be predict value. Okay, okay, predict value means y hat. Yesterday I have told you that y hat, after that our neural network is going to be predict some value, that is y hat. Okay, in first time, understand something importantly, first time we initialize the value of weight. Okay, after initializing, according to our output, we trained all the model. Trained means, training means what, we are giving the perfect or more accurate value, more accurate, okay, value to the w1, w2, w3. Okay, so that our, for new data, whenever now new data will become, they are going to predict according to their weight and biases as well. Okay, in every neurons there will be something called bias term. Study same I have told you. Okay, if you have remembered, I have written one formula, y equal to mx plus b. So here we can call m as a w, and here it is a B. Okay. In the term of neural networks, we call as a weight. Okay, weight and nothing else. B is bias. Okay, bias term. In same way we are doing here. Okay. So firstly, we understand how many types of neural network we have. Okay, types of uh, ANN or NN. Some people used to call neural network only. Some people used to call artificial neural network. So there is not any difference from this. Okay. So the most important neural networks that everyone must have to know, that is MLP. And before MLP, if you are performing simple linear regression, that a static class, that is the part of machine learning. But you can call as a perceptron only, PA only. Okay, I will tell you. NLP means multi-layer perceptron, perceptron. Okay, then something new called CNN. Yes, CNN, convolutional neural network. Then something more like RNN. Yeah, RNN, recurrent neural current neural network. Okay, and more updated version of RNN, LSTM, long short term, long short term network memory, memory. Okay, then something more advanced LSTM parts, that is GRU. Okay, gated recurrent network. These are the updated version of this one. Okay, only the changes will be only in the structure, how we are designing our neural network. Even at all the things will be going to be same. Okay, so these are the most used ANN techniques. Okay, and some more advanced, that is transformers, etc. Okay, transformer transformers, then GAN, etc. These are, they are multiple one. Even that every day some some person will be design some new neural network concept. But base are these things only. Okay, you just have to understand all these things. It means that you are going to get all the knowledge of neural networks. Okay, so uh, I'm just making one difference. Okay, in machine learning, what we do, we have to do feature engineering. Machine learning, we have to do feature engineering, right? Like we have a data, we have to convert this data to the proper format so that machine can be learn. Okay, currently it had messy value. Okay, maybe here written no, yes, but we have to convert this data to machine readable format. Means like for no we use 0 1 like that, and these all the things will be done inside the feature engineering. Feature engineering is a very vast area. Okay, so this is just I'm giving you simple examples. Also some places we have empty space, so we have to fill them with some value. So this filling of the value, blank value, is also done by the machine learning, with the help of machine learning. But in that time we just use single feature, work with only single feature, and we fill, like we have to, like we have to 10 row containing 5 4 4 5. So if we have here one blank space, means that position is not filled up by the any number. So what we are going to, we have to find mean, and the mean value is going to be, we are going to put here. So we got 4.5, so we put here 4.5 or something else. You can put 4, or we have different techniques to fill the form. Okay, like if we have a date system, date. Okay, if somewhere date is 12 1, then 13 1. If one date is missing, okay, then 14 1. 1 is basically a month, okay, and 15. So what we are going to put here? We are going to put here some, 14, 15, 16. Then we can here put here 14, 14 month, 14 day. So according to the situations we are going to fill, and this all the things will be done inside the feature engineering. And who will be done these things? By humans. By humans. Means human involvement. Okay. In deep learning, same, this feature engineering part is done by the machine only. Here machine will be. Okay, that's why it is very important, and that's make any what will say neural network very more advanced. Okay, even neural network is going to work with undefined data as well as, okay, by learning from the data. But in this case, our model is going to be a static. So because we are trending on fixed amount of data, what our amount input data are also fixed. Okay, but in this case we have flexibilities. That's why it is more advanced. That's why we use mostly deep learning. Okay. But we have to understand first machine learning, right? Then only we are going to learn deep learning. This is ABCD and this is advanced. From this advanced, we are chat GPT. Everything is going to make from this one only. Okay. Even chat GPT use CNN architectures plus RNN architecture plus LSTM architecture. They used in multiple ways. Okay, if you write in ChatGPT, hey ChatGPT, can you explain about me? What you think? What I am? Then he is going to use LSTM, long short term memory. He is going to pick your what are the searches you have done in past, in long term, in short term, what you are currently searching for. Okay, if you are a UPSC candidate, then he will understand, okay, you are a UPSC candidate, you are preparing for the UPSC, so like that only. Okay, if you are a AIML researcher, then he will say you are a fascinated AIML engineer, so you are doing this type of project and you are working on this. So how they are telling about you? By using this technique. And here we go. Okay. Okay. So I have shown you one artificial neural network. Okay. Now I will be tell you how single perceptron work. Okay. When you will understand how single perceptron work, then you are going to understand how each perceptron is going to be work and how this weight value is going to be decided by the developer, or you can say AI engineers. Okay. Or machine. Okay. Not only W1, B as well. Okay. Here also means you have to understand each and every connection have a weight. Each and every connection have a weight and different weight. This will be X, Y, Z, like that, etc. Okay. Okay. So I will do one thing. Perceptron. Okay. So basically, what is perceptron? Perceptron is a single unit. Okay. Let this circle that I have shown in hidden layer. This single circle indicate this is perceptron. Okay. In perceptron, we got multiple inputs from some input file. Maybe it will be CSV file, something. X1, X2, X3, X4. These are the features. Remember, these are the features. Features means column of the table. In the table, we may pass four features. Okay, one, two, three, four. These are okay, and we have to predict y1. This is y. Okay, y hat. This is y hat, and these all are the input x. Okay, so this is x1, this is x2, x3, x4. So in single time, we are going to put single row of data to the machine. That is x1, x2, x3, x4. Okay. After that, it is going to generate some output. Whatever. This is a simple structure where we have to train. What we have to train? Weight W1, W2, W3, W4. Okay, and also we have here two functions. Okay, one is summation function and one is activation function. Maybe some how I used to like fx. Okay, fx is a activation function. Okay, so I will write here. These are the features. X1, X2, X3, X4 are the features. Features. Okay. In simple word, general word, columns. Column of the table. Okay. Columns of the table for understanding purpose. Okay. Uh, in professional language, we always use features. Okay. And W1, W2, W3, W4, they are weights. Are weights. Weight. Okay. And also I missed out one thing. One bias for each and every perceptron. Every perceptron have their own one bias term. Okay. So z is summation function. Summation, sum of weight and bias. I will be writing. Okay, don't worry, I will be write all the formula. And fx is activation function. Activation function. Okay. And b is bias, and y hat is predicted value. So in previous time I have told you KP is nothing but simple machine learning model. Okay, so if our neural network will be have neural network have single perceptron and it is giving some output, then it will be simply work as a similar. Okay, even you can say 98% chances. Okay, 98% similar, 98% similar to the linear regression. Okay, if it will be the multiple line, so it is going to be learned with complex. Okay, so perceptron is just a basic components. Okay, basic components, keep in mind. Okay, so there is a very one more good concept uh, what will say came by the perceptrons. Early times when our researchers are working, they are basically working on 0 and 1 only. Okay, at that time they find out something called like this. Okay, I will tell you. This is let 0, this is 1. Okay, this is 0, this is 1. Binary operations. Okay, so 0 0 is always going to give 0. 0 1 is always going to give in multiplications. It is always going to give 0 in 0 in multiplications. Let me in multiplication 0 1 0 and 1 1 1. So this data we can separate from by using single line. Okay, if the any points come below the line, it will be come under the 0. If it will be the above the line, it will become under the 1. Okay, in the same case of addition as well. Addition like 0 0 1 1 for addition. This is for multiplication, this is for addition. Keep it in mind. Okay, in this case 1 1 1. Also, what we can do, we can draw a single line and we can separate the point. But if we have a XOR operation, XOR operation, at that time, okay, what have 0 1 1 0 0 0 is always going to become 0, right? 1 0 1 1 0 1 1 1 0, right? So in this case, you have to understand, okay, if you have to separate this line, we can't separate with the help of single line. It is not possible. If you try to separate by this, wrong. If you try to separate by this, it will be also wrong. If you try to separate with this, it is wrong. So what we have to do, we have to draw multiple lines. Okay, one line will be this, second line is going to be this. Okay, so this is complex. Okay, and that problem is not solved by the perceptrons. That's why something new called MLP come into the picture. Multi-layer perceptrons, MLP. Okay, I hope that you are understanding all these things, right? It maybe looks complicated, but it is not. Okay. I will also explain you what are the different types of activation function. Okay. So uh, this is the basic work of the Pepseton. Okay. Now we have one question. Okay. What is Z? What Z used to do? Z is nothing but summation. Okay. Summation of multiplication with each feature with their weight. Each feature have their own weight. You can see here, right? Each feature with their weight and addition, extra addition. Okay. Plus with pies. Okay. Means you can, in simple word, you can write summation I equal to, if we are starting from 1, then 1 to n. Okay. It will be here in the here n value is 4. Okay. Xi plus wi. Sorry, into right, into wi. Xi into wi. So this is basically a z. Okay. Summation function. In last you can add plus b pi st. Okay. So this is provided by the this summation function, and this summation value is going to go through with activation function. Whatever the value will with z will become, we can pass to the fz. Okay. And z will be different function, activation function, like tanh function, sigmoid function. Okay. Or relu, etc. It may be tanh, it may be sigmoid, it may be relu, etc. etc. According to the situations we are going to put. Okay. We will see in after MLP. I will be teach you what are the sigmoid function and what these are going to help us for. Okay. I will tell you, but just stay focused on this one only. Okay. So now we have to wait one second. Hmm. Okay. So I'm just going to give you a now quick revision for MLP. Okay. So stay focused. Remember one thing. Yesterday I have already told you how this model is training, because this is same as a linear regression. Okay. So whatever mathematical concept yesterday I have told you, same mathematical concept is going to be work here. Okay. Okay. And one more thing I have forgotten to teach you, that in first time we initialize this value. After that, by using back propagations, it is going to learn what will be the correct value of these all the uh, weighted and bias back using back propagations. Okay. In MLP, we are going to understand in more clear way. Okay. So let me draw some multi-layer. This is called multi-layer perceptrons. So now, previously we have only one perceptrons, but now here multi-layer perceptrons means we have multiple layer as well as perceptrons. Okay, means our data, our structure is going to be some messy than previous one, like this. Okay. Again, I am assuming x1, x2, x3. These are the features, right? Same way. I'm not going to write you again and again. If you want what are these, you can go here and you can check. Okay. So x1 is going to pass through all the perceptrons, these three perceptrons. X2 is also pass through these all perceptrons, and these three are also going to pass with these all the perceptrons. And X4 is also going to pass through the all perceptrons. Okay. Yeah. Okay. So again, these are passing through this thing like this. Okay. Now again, and at the end of this, we are going to get our y hat. Okay. So how we how we give the name of all the weight and biases. We are not going to simply give you one the weight 1, weight 2, weight 3, weight 4. for multi-layer percentile, right? So we have a right way to write all the weight value and bias value. Okay, let also here we can write as a I1 I1. Here we can also write as, I will write again for this naming culture. Okay, why I'm writing this one, and I will tell you. Just stay focused. I2, this will be I3, this will be I4. Why I am writing this one as I1? Because we have four features, that is X1, X2, X3, X4. Four features. But for first row, it will be I value will be 1. So X11, X12, X13. That's why. For second time, the next new feature is going to be came here. Means value is going to change every time, right? Here for loop will be run work. Each time new row is going to take and given to the neural network. That's why I11. I represent row and 11 is represent feature. Okay. So now again, and now we are going to give the name of weight. Okay. If we are in first layer, then we are going to give W1 like this. It means that each and every layer, here also W1, but this layer is came from the first feature. First feature, we have to just focus on the first feature. So write word first feature are going to the in second layer first perceptrons it is going. So we write as 1 1. In same way, if you are going to take example of this brown color line, middle brown color line. So here what will we do? This is also weight. It is from the first layer, so W1 coming from the 3 and going to the 2 to 3 2. In this way, we give all line all line or all connections, or we can say all weight. In this way, we give the name. Okay, and this here it contains some bias, right? So we can write as a 1 bias, B12 and B13. No confusion. Okay, some people used to write like a B11. So no problem. Okay, because biases, every perceptron have only single biases. Okay, one single one defined this, or this one defined layer, and this defined position. Okay, position same. Now here also new weight will become. So in second layer, weight 2 come from bias 1, sorry, perceptron 1 first layer and going to the perceptron 1, then W211. In this way, this yellow line, second yellow line will become weight in layer, first, second layer. It is coming from the second perceptrons and going to the third perceptron second. It will be 2 2, right? If you are going to take about a last brown one, it is also in second layer coming from the 3 and going to the 2. In this way, we give all the name. So you have to guess what will be the name of this one, and this one. Here also with final weight. Okay. Okay. No wait. Sorry. Here we don't have to provide the weight. Okay. Because directly we are getting the output. Okay. So in this way we provide the percentile value. Now in first time we initialize the value. If we are initializing the value, it means that model is not well trained. Okay, for different row and columns, it is going to work as the same as every time. Okay, so what we do, we have to let them teach by themselves only. Means in deep learning, you understand, each and every perceptron's weight and biases is going to train by itself only. Okay, and how they are going to understand? By using back propagation. They use one concept called back propagation. Propagation. By using back propagations, they used to train the weight and biases, weights and biases. Bias. Okay, so if we look at these pictures, how many weight we have, weight we have to train, and how many biases we have to train. If you focus here total we have four 3 is a 12. 12 weight we have to train, right? And how many biases? Bias. Here bias term is 3 bias. Okay. Again, here we have 6 weight. 6 weight. Again, here we have 2 bias, right? Again, we have 2 weight. Okay. And last one bias. One bias. So how many parameters we have to train? Just focus here. We have to add all of them. Okay. So 12 plus 13, 15 plus 8, 8 to 10. Okay, 20. 15, 20, 25, and 1, 26, right? So total 26 parameter we have to train. Once again, we have to train 26 parameter. If you in first time we are going to initialize 26 parameter by any values, okay, according to our situation by using different technique. But at the end, machine will be machine is going to use back propagation technique to to train the 26 parameter. Okay. Uh, Yesterday I have told you that there maxima minima, right? So by using that maxima minima concept only, we have predicted value, and we what we'll say sit we have already given some value. Okay, if the difference will be too much, they try to minimize them. They try to make them close that, so that for new data it is going to predict correct one. Okay, so back propagation is nothing but it is just differentiations. Okay, chain rule. Okay, I'm just going to give you one simple okay simple illusion, so you are going to understand. Let okay, just focus. If now I have to give the name. Okay, if you are assume this one will be come into W311, and this one is W321. Okay, from 2 and 1 1. This will become B21, or this will become B22. Okay, so if I'm just going to give you any weight, and you just have to understand how that weight is going to trend. In similar way, all the weight is going to be trained. Okay, so let I am going to assume this one, brown one. Okay, how we are going to train this one? So W232 value is going to depend on the error of Y. So firstly, we have uh, something called loss function. With the help of loss function, we are going to differentiate with Y. So we will get some a small rate of changes. So whenever we are going to make a small changes, what is going to affect on this? But still, we have in between them, we have multiple things, right? So again, we are going to multiply this y hat with this bias term. This is called B31, right? By bias term B31. Then that B31 is if you focus on 32 is depend in this line, so it is dependent on B2 and then this one, right? And this one this one is depending on this one. So in that way, sigma sorry, differentiation D B31 divided by summation of say differentiation with respect to W321. Now with 21, we are going to get this bias term into, because these are dependent. Whatever changes making by the making in B22, that is going to affect B32. That's why I'm writing in chain rule. Okay. No, 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 not B22. We don't need B22. Why? Because B222 is just a separate part, okay, part of the persitons. So wait directly, wait W332. Okay. Here in between this, we have some activation function as well as if we are adding some activation function. So we also include here fx function according to the function that is going to be decided. Okay, but in simple representation way, we can understand one thing that if a small rate of changes making by making in wy, loss function is nothing. It is you can say like y minus y height whole square. We have a study we have learned, okay, we have to minimize this error. So with the help of this loss function, we are going to make a small rate of changes in the y, and that changes is going to affect this one, okay, b13. Okay, uh, we can call as a neural network b31, and that is going to make changes here, that is also going to make changes here, and that changes is going to reflect to the weight 232. In this way, we train the each and every weight and biases. So this is a basic simple way of understanding how weight and biases is going to train by the machine. Okay. So one more thing, uh, what they use, okay, like how they are taking the differentiations and how gradient descent basically going to be work. Okay, gradient descent means differentiation, a small rate of changes. Okay, uh, because whenever you are making a small rate of changes either in positive way or negative way. Yesterday I have already given you one illusion like this. If we have to reach here, okay, and we are here, if we have to reach to this point, then we have two way, either we have to go to upside or either we have to go to downside. So how this is going to decide by the machine, because machine is not a god directly it is going to be reached here. It may be time, it will take some time to move from here to here. Okay, this is nothing but a small rate of changes. Okay, sometimes we provide some uniform rate of changes, like each in each and every time it will be jump 1 unit. At that time at that time uh, the point will become here. But if we will give 5 iteration, we are using five time loops, then what, first, second, third, fourth, fifth, it will be like that, na? So we are at the end, we have the reach to the minimum point, but again we are going to move to the up direction, that is in the wrong direction. So still we are not reaching here, this point. Again, again we are doing, means in this situation we are going to use some different concept. We are using like undefined value, like random, any random random value. That time this value is come here. If you are putting any conditions, okay, if it will be in minimum, it is maximum, it is minimum, then don't go up. Okay, stop here. Still we are not able to reach to the endpoint, means after putting condition as well as maybe we have chances to that we have missed out the minimum, global minimum, okay, or loss, minimum loss, global minimum in the term of mathematics and loss in the term of AI. Okay, uh, so for that we use GD, gradient descent. Okay, whenever you are going to train any model, you have to provide what kind of training we are going to use. Okay, so first is that whenever you are providing each sets of data, set of input data, like here we are providing just one row. It may be happen that you are providing in one time we are providing 5 rows. Okay, okay, if you are doing like that, then that will become under the batch gradient descent, batch GD. If you are providing uh, what will say single data, okay, one data at a single time, that will become SGDK, SGD, है ना? That is come stochastic GD, stochastic gradient descent. Second one, third one, mini batch. Batch means large amount of data. Mini batch means we have to decide how much a small data input size will be. According to that value is going to be found out. Then that is mini GD. Okay. mini GD. Okay, so these are the different gradient descent techniques that we have to do. Okay, but keep remember, uh, if this data is already always going to work with this tabular data, then why we need other deep learning methodologies or other neural networks? Because when in MLP the problem is like that, it is not going to work with images, right? In images, if you focus in single term, single images, that single images may be contain thousands, hundreds of million, thousands of pixels, right? So for each pixel we have something called weight. After that only that our model is going to generate picture for us, right? So in that situations MLP architecture is failed. I'm not telling you this is not possible with the help of MLU. It is possible, but it is going to take lots of resources. So what we do, we we minimize the input data. In first step, we have 100 and 180 pixel by 180 pixel. If we are saying that here in side 20 all 24 pixels are red, 24 pixels are red. So why should we have to provide each and every pixel to the training model? We can minimize them, right? If it is like 25, so we can only provide them 1 pixel for in place of 25 pixel. Okay, means in first time we have 180 pixel, then we have to minimize them, and still picture is going to be work very well for us. Okay, like let them 720 by 720. Still we can say that we can optimize them. Then again we make them a small. Okay, in like 720, let them as a 100. 100. I'm just giving you just example. Okay, so in this way we what we'll say, we minimize the input size. After minimizing, at the end we got let 10 by 10 pixel. I'm just assuming. Okay, it will be also in like a Messier structure, mesh. uh, Here it will be doing 10 by 10. Here also we have 10 by 10, 10 by 10, but this is taking top corner, this is taking bottom corner, this is taking left corner, right corner. Okay, every side. Okay, like that. You have to understand like that only. And so what we have done, we have made large picture into small units, or we can do some more. We can use some more changes like in channel. Channel is basically RGB. Channel is basically RGB. From RGB, we make picture in grayscale, black and white. In general term, we call black and white picture. Okay. So what happened in RGB? We have to store three value RGB. In grayscale, we just have to store in single value. So in this way, we minimize the large picture into a small data set. And after getting a small data set, like 10 by 10 means total 20 10 by 10 100 10 rows and 10 columns, right? Pixel is calculated like this only. So we have total 100 pixel, and that 100 pixel we can make as a x-axis like this data, 100 data. That is very common. Okay, and that data we can provide to the percetons, multi-layer percetons, or any others. So in this way, that is going to be work for us. And CNN use that technique. In RNN, we in RNN basically we are going to predict next upcoming world. Like whenever you are trying to print when in keyboard you try your name. If you try to print fill the your email ID on a blank box, that time whenever you are trying your just name, then automatically they recommended that this is your email ID. Okay, after clicking that you can directly fill that form. And how they recommending you that what are the input you are going to provide them. That's this all the things is done by the RNN, LSTM, GRU, these, and transformers as well. Transformers is also doing same things. Okay, but the difference is in only in architecture, how we are defining neural network. Okay, as I told you, we have 10 minutes to understand the activation function. Okay. Okay, so this is the basic use cases of ANN. Okay, so like I have already told you, Z is nothing but summations, and now in each and every pressure points we have a activation function, that is fx. Okay, and how fx is going to help us? Okay, ZD is used in back propagations. Remember, ZD always used in back propagations. Okay, and now activation function. Okay, like I'm just giving you one example. We have n number of data. Data may be verified from like we have to define one person is rich or not, rich or not. Okay, let assume if any person have a 1 CR, then that person will be come under the rich. If less than this, it will be come under the not rich. Okay, so what we have done? We have just draw one graph. Okay, this will be 1 CR. If the value will be above the CR, then that person is always come under the reach, right? We get something graph like that, or some people used to draw like this. uh, Poor, for poor it is niche downside, and for rich this one. Okay, this is the threshold value our 1 CR. But in input maybe we have multiple types of data. Maybe this CR value is coming from the different value, like bike price. Okay, bike, maybe auto, auto not auto, car. Okay, and it is okay. So these are the features basically, right? From that feature maybe we got something 2 CR or 4 CR value like that, but that value does not going to define in single term. We can do with one function. But if we have a different feature with different relationship, like we have given CGPA, we have given total marks. Okay, and we have given grade point. Okay, in the sports or different things. Then we have to find out that either people that particular student is going to be get the job or not. Okay, going to take the placement or not. At that time, these values are different, right? We're not going to simply add them and make them as a single term and we can predict. No, some places what happen, grade is very less. Sometimes CGP is high, marks is high, but a sport grade is very less. Okay, that person is not going to get the job. Some places a sport person have a high grade, CGP is very less, marks is very less, that is person is going to get the job. So in different scenario, uh, we have a different problems, situations. Okay, and that situations, what will we have to do? We have make them some value, and maybe it will be generate something called let one in general term, let them it generate 2 CR like that term. Okay, I'm just giving example. Okay, it means that what it should be get the placement. So in similar way here, I'm telling in rich or poor, we have seen, so we have to see each and every details. Okay, after getting that detail, we have to make one graph, and this graph, if you see, if it will be in zero, we can call them as a not rich. If it will be here, it will called rich. But there are not any other than rich or not rich. Okay, so whenever you are going to provide any fx value, that is always going to give you either rich or poor. In this case, rich and poor. Okay, f 3 CR, let it will give rich. If we provide 1 CR or 1.5 0.5 CR, it will come under not rich, right? So how? What these things are going to help us? This value is going to help us to find out the value, right? Like here, whatever y we need, we have y in same format. Okay, that is not going to give you out of the box answer. We don't need out of the box answer. So we have to make and concise the output in some particular way so that user can identify. If a minist data structure data set where we have to given 0 1 2 3 4 5 6 7 8 9, in that time in that if the model is using this one, each each number the model is going to provide us only the numbers, okay, not out of this. If it is providing 11, it means that our model is not doing the well prediction, right? So that's why what help us to make us in limit format, that is activation function help us to optimize the solution, okay. For the optimizations we have to use activation function. For different scenario we have a different optimization function, okay. I am going to give you some core activation function, okay. And also I will be draw the graph so you can understand that what that activation is making with changes, making the changes in the data. Because here you can see, right, data is coming from the input file, and that input file have some weight and biases, and weight and biases, and after that they will generate fx will be what, fx will be generate some y value, okay. So just first one, a step function. What a step function do, I will write you fx. This is just, you have to draw the graph and you will understand, okay. If x is greater than or, oh sorry, less than 0, okay. If it is greater than or equal to 0, it will come into 1. If it is less than 0, it will be come into 0. This is the basically a step function. How we cannot differentiate, right? If we are using activation as a step function, activation function as a step function, then we can't differentiate, right? I was told you here, whenever we differentiation term will become, that is also going to make affect the changes on weight. That's that time if we are using a step function, because we know that a step function is not differentiable. This is not differentiable, right? Differentiable, any equation is going to differentiate, right? So this is not differentiable, okay. Something linear function. Linear function, this is going to make our linear regression only, means fx as it is, no any changes, fx is fx. This is linear regression. Most used sigmoid function. Sigmoid function, this is very important. Fx equal to 1 by 1 plus e to power minus z, where z you know, right? Z, summation of weight and biases, right? This is basically z, okay. And this is differentiable. If you find their fx, f dash x, then you are going to get as a fx means same into 1 minus fx. You will get this one, okay. uh, you don't have to focus on this one, but it is differentiable. Just understand these things, okay. Now, okay, I'm so sorry, I have written one mistake. If I'm using here x, then here also I have to provide x only, right? If z, z, okay, z, z, okay. Currently I'm doing fx, then fx, x thing, okay. But just remember, x is this thing, this whole term, okay. Now, just focus on the function and their characteristics. I will draw the graph as well. Wait. For a step, this step function, if I is 0, means 0, 1 value. Here it is 1, right? So this one, and this is blanked. And for 0, it is circle and like this. For linear regression, if we draw the graph for the linear function, I have missed the linear. At that, in this case, fx is x, means whatever the value of x, that is the value of y will be going to same. Fx is nothing but y only, right? In sigmoid case, our graph is going to be like from 0, then 1, then here it will be 0.5. Okay, this is sigmoid function. Okay, it is differentiable and most used sigmoid activation function for the classification. Again, 10h, 10h, 10h function. Okay, 10h means we can here fx equal to 10h x minus x. Okay, plus x minus x. This is 10h function. Their graph is similar to sigmoid only, but a small changes. It came from the negative side and then go to the positive side. Means it work with negative value as well as positive value. Here you can see if we provide any negative value, it will be giving us 0. But for here negative value, it provides some value. Okay, not 0. Okay, so whenever we have a classifications and we have to take care that whenever we are going to multiply with something and we don't want value as a 0, then we can go for 10h. Okay, now these are very important activation function. Okay, next ReLU, rectified linear unit. This all activation function is inspired uh, by the a step function and linear regressions. Here fx is always going to be max of 0 and x. Okay, max 0 and x. Okay, it means that whenever the value is negative, it is not going to make any changes. It is always going to make 0. But if more than 0, that line graph is going to like this. Okay, so in similar way we have different activation functions called I will write just example likely ReLU, seventh ZeLU, etc. ZeLU, KLU, etc. Okay, so these are the activation functions. So whenever we are going to look for uh, any activation function, then we have to just taking the care of that what are the our data structure requirements and what prediction we have to do. If we have to classification problems or regression problems, like in classification problem we have to make them uh, each and every function is separate. So like if we have a 10 minist data structure, means we have to predict either that digit is 0 1 2 3 4 5 6 7 8 9 at that time. In the end of output, in the output perceptrons, we have total 9 perceptron, right? In that perceptron we have to provide them as a sigmoid. Why sigmoid? Because if the threshold value will be more than 5, then their value is going to become 1. And other numbers, like if user is passed 0 structure, 0, okay, 0, and that 0 is going to be trained by the model. Okay, here in model, if if at the end of the neural network, in this perceptrons, output first perceptron, we got 1. In other cases we got 0 0 0. Then we can understand, right, this value is basically a 0. If we provide something called 5, then by others we are going to get 0 0 0 0, but in fifth perceptrons we are going to get 1 only, in other 0, right? In this way we can say yes, this is 5, and this all the things will be done by the activation function. Activation function limit us. Okay, and that limitation is very important to teach the neural network. Okay, so this is all about the GD, And I hope that you got some good concept, good knowledge on AI ML. Okay, and in same way, other neural network is going to be work for you. Okay, so thank you. So thank you. I hope that you understand, and I hope that you have enjoyed this workshop, and at least you got some concept like what are the things and how we are going to learn and how this is going to help us. Okay, so you in first class I have teached you that what is AML and what are the roadmaps. Okay, and in second class we have seen linear regressions model. Uh, okay, linear regressions. And in third class, we have this how deep learning is working in backside. Okay, with mathematical illusion. Okay, so thank you, and